Hey guys, wanted to do a bit of a baseline experiment on a supercapacitor to then do some variation on and see what happens when I change a few things. Let me explain my rig. I've got some lithium batteries in here powering a BC3603 power supply, which is really cool because I can set it to 2 volts and also set the amps, which I've opened up to 1 ampere max, but it's only pulling 31 milliamps at the moment. And that's charging up a couple of layers of carbon fibre, 3 inches by 3 inches or 7.5 approximate centimetres, both sides, and I've wet it with some half molar sodium sulphate that I had hanging around for other reasons, just as an electrolyte. So that's effectively charging 2 volts into this side. I've got a multimeter set up which has got some rough batteries at the moment, so it's showing 1.7 volts there on the effectively the output side. Come back to that in a minute. I've got this little motor that I pulled out of a Phillips shaver some time ago, and I've popped a little bit of plastic tape on the end just to see it rotating. So this is a pretty basic supercapacitor. There's no active material, any carbons or anything across these collector plates. So the performance isn't going to be great, but I really wanted to set a baseline where I could effectively get multiples of this thing by adding different materials to the same sort of blueprint, changing separators, which at the moment is rather unashamedly a standard piece of 2-ply toilet paper. So I've charged it up anyway, and I'm at the 2-minute mark. So what I'm going to do is turn this off and count it down. Two minutes 21, so that's 21 seconds to run it from 2 volts down to what's effectively 0.3 of a volt. The reason I know that is because I put this power supply directly through to the motor before and blueprinted it into a spreadsheet where I was able to start down at 0.1 volt and gently bring it up 10 millivolts at a time and look at when the motor started to spin. Then I noticed that it was spinning at 0.4 of a volt. But then I took it up to 5 volts and then brought it all the way back down again, measuring the no load milliamps, because this thing allows me to crudely measure milliamps, and I'm not taking it as accurate, but I am taking it as relative each time I come back and do another test. So what I was able to see was that the motor would get down to 0.3 of a volt on the way down and then stop spinning at 0.31 of a volt based on this voltmeter. As I decremented that, I was able to also measure the no-load current. So what I'm thinking is I could also connect an Arduino across here, measure the millivolts, and because I've blueprinted this motor, I know what the no-load amperage is, and I could effectively calculate watt hours of each cell that I make now based on this standard template. I think what I might do is come back and actually swap this motor out for a standard Banggood motor, because what I'd like to do is collaborate online in the Facebook group with other people building cells, and if we all use a standard motor, then that gives us a benchmark.